Hi folks, welcome back to Physics with Captain Rod. I'm making this video here to introduce you to two very important concepts in physics, potential energy and kinetic energy. So in order to understand this video, it's important that we have some background knowledge here. So energy is the ability to do work. So if you're not familiar with that, you can go back to one of my previous videos or probably any number of other hundreds of ones that are available, or thousands probably. And we're going to talk about a couple physical cases here. We're going to talk about this young man, Timmy, here, that I like to use in a lot of my pictures, standing on the end of the building, the edge of this building here. And for the purpose of this example, don't worry about Timmy. We're going to define our system here as the basketball and the earth together here, and really just focus on the basketball. This system here, there is work that could be done here. If Timmy lets go of the basketball, the gravitational force on the ball is down and equal to mg. And this is some height that this ball is starting from. So there's work that could be done there. As the ball falls and accelerates down, the gravitational force is doing work here. And the amount of work that's done is pretty easy to calculate. The force is mg over the distance h. So the work done by gravity as the ball starts at this position and falls down to this position, work done by gravity would equal the term mgh, which I'll talk about later. So you notice that there could be work done. Also notice the higher the ball starts, like imagine Timmy dropped the ball from here, there would be more work done because the h is larger. Imagine that somehow maybe Timmy dropped the ball out of this second floor window here, where the ball started from here and fell only this distance. Now there'd be less work done. So notice that there's the ability for work to be done, and notice it depends on the height of the ball. Another example to chat about, this bow here. So imagine somebody has drawn this bow back to the position shown. The somebody is not important for the picture. Imagine our system here is the bow and arrow. This system has an energy associated with it because there could be work done. When the person lets go of this string, a force will be applied to the arrow in this direction. And then when the arrow starts moving in this direction, some distance, there's your work. This example, I was trying to think of a very acceptable example here of what this car could be running into. So imagine this car is moving down the road, and maybe it's going 20 miles an hour in this direction, so it's got some velocity. And somebody left some sort of toy boat out in the yard here, or like right in the car's path. So if you think about what could happen here, if the car comes in physical contact with the boat, it will apply a force on the boat in this direction, and the boat most likely will start moving in this direction. So now there's work being done. So all three of these systems have the ability to do work, or I think I should state it like this. In all three of these cases, there is the ability to do work, so some sort of energy is present. In the case of the basketball, the amount of work done depends on where the ball starts. In the case of the arrow, the amount of work done depends on how far back this string is pulled. If somebody pulls the string back a little further, the bow can do more work on the arrow. In the case of the car, how much work could be done depends on the speed of the car. If the car is moving very, very, very slowly, like 1 mile an hour, it probably can't do much work on the boat. I mean, unless the driver gives it gas. But if the car's moving really fast, like 30 or 40 miles an hour, now the motion of the car will allow it to do significant work on the boat here. So there's really two different types of energy present. There's what's called potential energy, which is defined like this. This is how I define it. Potential energy is defined as energy due to position. And we also have, in the case of the car, what's called a kinetic energy. And here's how I define kinetic energy. Kinetic energy is defined as energy due to motion. So these two cases, here and here, carry a potential energy. In this case, we would say the car carries a pretty reasonable kinetic energy. So that's what potential energy is, energy due to position, and this is what kinetic energy is, energy due to motion. And I think what I'll do is I'll save equations for the next video. I hope that this helps introduce these concepts. Have a great day.